Hello, my name is Susie Lee, and today I'll be delivering a research talk for my project Knowledge Maps. This is for the quarter fall 2018. I'm going to start off by defining the problem. In a very general sense, it's about answering this question. How do we overcome the gap between novice web developers and professional web developers? Now, in order to really motivate why this problem is a compelling one, I should define what novice developers are compared to professionals. Generally speaking, professional web developers have two depths of knowledge. One of these depths is knowing and understanding all of the different ways to implement a single feature. And by feature, I mean like maybe a particular website layout or like how to implement like a footer or a header and so on. The second depth that professionals have is knowing how one approach or implementation can be used to create a variety of different web features. Because at least in web development, there are lots of features that look visually very different, but are fundamentally using the same kinds of CSS attributes, our same general idea of implementation. Now, with novice web developers, they often have a pretty superficial syntax or code level understanding of CSS concepts, and they lack one or typically both of the depths that I have described. Here is a more solid visualization of what I mean by these two depths. So we can see depth A, where one approach can be applied to multiple different features, feature A, B, C. And on the right, which I'll call depth B, you can see how one feature can be created using all of these different CSS implementations. And throughout this entire research talk, I'll be referring to these as depth A and depth B respectively. So here's an example. A concrete example of depth A would be recognizing that all of these different web features are implemented in the same way. Of course, you would also be provided the CSS code, but it's still surprisingly difficult to notice that all of these use the CSS fixed position approach, in which you basically fix a particular element to a certain part of the viewport so that it doesn't disappear when you scroll the website around. This exact same approach is often used for headers, footers, and navigation bars, or just elements that web developers want to be fixed on the screen constantly. A novice is probably going to be confused by how different all of these elements look like and not recognize that all of them use the same fundamental approach. So there are definitely many existing approaches that try to help novice web developers become professional ones. However, these do not fully address the problem for several reasons. First, all of these approaches often focus too much on syntax. Although a low-level understanding is certainly important for code replication or feature replication, a true professional should also have a more generalized understanding of what's going on. And this occurs because most novices are very impatient and want to immediately start implementing things, and it may not be in their immediate motivation to also gain a high-level understanding as well. Something particular to Ply is that it's very effective for individual code replication, as in if you have a particular web feature you want to replicate, then Ply does the job great compared to CDT. However, it is not great for understanding or identifying similarities across several web feature examples, or being able to group and notice patterns and get a larger picture. For online courses, like on Udacity or Udemy, these only work with a very small subset of examples that they provide in the online course. And these examples are often oversimplified and do not reflect what you'll see in the wild on the World Wide Web. So, the general conceptual approach that knowledge maps will take to tackle the problem is to scaffold novices into creating their own knowledge maps, aka groupings, so that they can spot new connections or new similarities between examples organically on their own. The main challenge here is how we actually scaffold novices into spotting these certain very um, and spotting certain connections that may not be intuitive or obvious right away on their own without having to spoon feed them answers and CSS concepts like an online course. So here's a summary of the contributions that I made to my project over this quarter. One is I conducted a pretest to help get an idea of how to design my initial prototype. After that, I designed a lo-fi prototype, and I wrapped up the quarter by conducting a study on said prototype. The general results, which I will go over later in more detail, is that the prototype does do its intended job or the goals to a very small extent, but not as much as I would wish. And the participants' prior CSS knowledge often significantly hindered the ability to create a meaningful knowledge map, which we'll also expand on later. Now I'll go into the design arguments. I'll present these along with the characteristics of my prototype because I find that to be a lot more informative. My first design argument is to make novices build knowledge maps from a set of provided examples so that they spot common CSS approaches amongst examples that they would not have noticed before building the knowledge map. So in the context of my prototype, the novices were provided 10 web feature examples along with the CSS code and were told to build a knowledge map with them. And the pre-test and the post-test, which you'll see later on, we checked like which of the connections they spotted or not before and after. The main obstacle this is addressing is that novices cannot see that a common approach is used across several examples because they just haven't looked deep into them and just haven't had the chance to really explore them, manipulate them, see how they really work. And building a knowledge map scaffolds novices into really interacting with the examples because they're now motivated to group them in certain ways. The second design argument is to provide novices with the logic of a good knowledge map so that they're scaffolded to make meaningful groupings and connections. The most important part of this design argument is the last bolded part, meaningful groupings and connections. Because I noticed that in the pre-test that I did, when participants were provided minimal scaffolding, they gravitated towards very superficial or obvious groupings that did not push them to explore the CSS code or implementation. And that became a huge obstacle. So this design argument hoped to address that directly. And in terms of the prototype's characteristics, this manifested as providing the novices some examples of knowledge maps that reflected depth A and depth B. In order to prevent bias, I did it in terms of different kinds of dishes and how to make them. So my third design argument is making the users, or allowing them, I suppose, to compare multiple examples and their relevant CSS code side by side to facilitate their ability to spot similarities and differences. Main obstacle this is addressing is that it's difficult to spot, especially similarities that are not intuitive or not immediately obvious, unless you can see the CSS code right next to each other or the web features right next to each other. In the prototype itself, I just printed out all of the examples with their CSS code so that the participant could just rearrange them, group things, and see a bunch of them side by side on a surface. Now we'll go into the study and my core findings. The study setup was a pre-test, the prototype test, and a post-test. For the pre-test and the post-test, I used the exact same checklist with a list of connections or groupings of examples that I hoped they would notice. For example, I would ask them something like, oh, is there something similar between examples A, B, and C? If they notice that all of them use the sticky header implementation, then I put a check and so on. And then in the middle step, I make them build a knowledge map where I also record what their process is for creating the knowledge map. And then the pretest and post-test, I see whether after they created the knowledge map, if they checked off more stuff on the checklist. One of my takeaways is that the act of creating a knowledge map does help novices notice common implementations they didn't see before to a very small extent. They notice an average of 1.5 more connections than they did before building the knowledge map. A quote here is, "Oh, I didn't notice that all of these examples used flex before I started grouping them together, and those are things that exactly reflect what we want." The implication here is that we may need more scaffolding in our prototype to make it easier to see these connections organically, because although it is nice that there is some kind of effect, it's not as large as we would want it to be. Another takeaway is that novices gravitate towards making low code level comparisons and connections, so they need significant prodding to even try to make a more generalized grouping. I noticed this because in all of the verbalizations, the explanations were always in terms of the CSS attribute values, like, oh, the flex direction attribute was vertical for these two examples, and we want something more general. The implication is that we need more scaffolding to encourage high-level generalizations. The third takeaway is that a novice's shallow understanding of general CSS concepts can significantly hinder their ability to create meaningful knowledge maps. Novices may latch onto the wrong CSS attribute. One notable example was when a participant overamplified the importance of WebKit, which is just basically a prefix on existing CSS attributes to increase browser compatibility, but he thought it was a whole different CSS approach on its own, which is not true. The implication is that perhaps these novices need at least some kind of refresher on basic CSS concepts so that they know enough to not hinder their ability to build a meaningful knowledge map. So what did I learn? I learned that the current prototype works, but it doesn't work well enough, and I should go through some more iterations in its prototype design. I also noticed that a participant's lack of understanding of just CSS can really hinder getting some good results, and I need to account for this in future study designs. So for the next steps, I'm planning to create a high-fidelity prototype based on the implications I got from the study takeaways, which I mentioned before, and then I want to conduct a study on it. And finally, the act of building a knowledge map does facilitate learning. However, more scaffolding is necessary to make it a very effective and efficient learning experience. Thank you.